expert funda, and in today's video we are going to tackle an important and very important asked LinkedIn problem. And so this question is getting asked multiple times in the interview, and it's a very good concept on the linked list. So let's understand today. And the question is saying that we have to remove the nth node from the end of the list. Okay, so this is the preparation list, right? FAANG interview preparation, where I have already uploaded a couple of videos and we'll discuss more about that. So before that, let's understand Leetcode 19. We have to remove the nth node from the end of the list, right? And the statement saying that we have given a head of the list and we have to remove the nth node from the end of the list and we have to return its head. For example, if we have a list, linked list, so node 1 is having node 2 and node 2 having 3, node 3 having 4, and node 4 having 5, right? Like this, each node is connected with another node, right? How? Because it is linked with others. That is why it is called linked list, right? A list that contains couple of nodes to each other means this node knows the address of the next node, right? So it is pointing, and so it is saying you have to remove the nth node from here. Okay, so nth node will be given, right? And the list will be given, head of the list will be given, right? So head of the linked list will be given, right? And the nth node, remove the nth node, right? So that will be given. Okay, now think about example. So let's suppose we have a head that is 1 2 3 4 5, and it is saying n equal to 2, means we have to remove the nth node. What is the nth node? From the end. So we will start 1 2, means you have to remove this 4, right? So the output should come what? 1 2 3 4. Once we will remove the 4, this will be output and you have to return it. Okay, if you talk about the example 2, where if the element, if the you can say element in the linked list is only one node, that is 1, and you have to remove the n equal to 1, means you will have to remove this element itself, right? If the you can say head is having value 1 and 2 and n is equal to 1, we will remove the 1, right? Because we have to remove from the last, right? So last will become 1. I hope you understand, right? Let's understand the constraint that we have given. Let's suppose the number of nodes in the list is SG, right? So it is greater than equal to 1 and less than 30. Maximum 30 node will be given. And if you talk about the node.val, it should be between 0 to 100. Okay. Now understand the example that we have given. So there was a first example that we have given is head we have given, right? And head is 1 2 3 4 5, right? And n equal to 2 we have given. So if you talk about the output, output is 1 2 3, not 4 5, because 4 we have removed. How? Let's suppose we have given these heads, right? Like this. Okay, means if head is given, means head is pointing to the first node, and if you have the first node, right, it means he has the address of second node have the address of third node. Like that, you have all the nodes information. So this node doesn't have any value, so it will point to the null. Okay, it means if you represent this, these are the node. So each node contains what? Data and address of the next, right? So each node contains what? Data. What is data? 1, right? And the address of the next node. Okay, so each node, all of these nodes that you are seeing, right? 1 2 3 4 5, right? All nodes having what? Data, right? And the address of the next node, right? Means this node is 1 and first node have data 1 and address of the next node it have. So it is linked, right? So each node is linked with another node. Why? Because this node is a, let's suppose, a class. This class have a int val and the next node data, right? Itself on the next node data. Okay, that we will talk more about in this video, so don't worry. Okay, just think about that the head is pointing to this position, right? This node, and if the we'll talk about this, means doesn't have any next new node, means this will point to null. If n equal to 2, right, what we have to do means, if n equal to 2 means we have to remove this node, right? The fourth node that we have to remove means second last from the what list. This is 1, this is 2. So this node we have to delete. Once you will delete, right, if you remove, you can say your updated linked list will be like this. It's still pointing to the head, so you have to return the head and you will get the data, right? So if we want to remove the second node from the end, means n equal to 2, right? It means we have to remove the node, that node, and once you remove the node value 4, node with value 4, you will have the updated list like this, and you have to return it again with the head. Okay. Now think about how it is removing, right? So previously 1, 2, 3, 4, and 5. These are the nodes we have given, right? So as I told you, each node contains data and the value of the next node, right? So next node value means what we are doing. So the 3 will, it was pointing to the 4, right? But it will now point to 5, means fifth value node with the 5 value, right? It will point to here. It will not point to here. Okay, why? Because if we will remove this link from here to here, right? If we remove the link of next link means next node value, right? No, next node value of this node 3 from 4 to 5, right? It means it is dereference, right? It means it has, we are removing the reference from 3 to 4. There is no link, we have unlinked it, means there is no linking between 3 and 4. Now 3 and 5 have the link, right? So whenever we will get the head, if you return the head, head will point, 1 will point to 2, 2 will point to 3, 3 will point to 5, not the 4, and so on. Okay, what will happen to 4? We'll talk more about in this video. So let me tell you that this is the playlist of FAANG interview preparation, where I have already uploaded a couple of videos, right? And I'll keep adding this playlist for 180 days preparation of the FAANG interview. So I'm taking almost 6 months for the preparation. So please keep watching this video. If you have not gone through, prepare your notes. There are a lot of information and tricks, patterns, everything is there. So keep watching this video. You will get the logic, how to build it, your basic concept will get prepared. If you have still any doubt, please ping me in the comment box. So I'll create a video related to that. Okay. Let's understand the intuition, right? So what is intuition here? Just think, you have gone through the statement, right? So we are given a singly linked list, right? And having asked to remove the nth node from the end. But here is the challenge, right? We don't know the total length of the list in the advance, right? Means if we want to remove the nth node from the end of a singly linked list, right? If we want to remove the nth node from the end of a singly linked list, then what is the problem is here, right? See, we don't know the total length of the list in advance, right? We don't know. This is our challenge, right? We have given the singly linked list, right? And they are asking us to remove the nth node from the end, right? So in the singly linked list, if you want to remove the nth node from the end, right, there is only one challenge, that we don't know the length of the list upfront, right? If we don't know the total length of the list in advance, so we can't directly count length minus n to find the node to delete, right? It means we have the challenge that we can't directly compute length minus n to locate the node exactly, right? So if we can't directly count length minus n, right? How many? Let's suppose 5 node is there. We'll do -2, right? It means it will come where? Third node, right? Index a third node, right? Let's suppose. It means if we will not compute this, right? So we can't directly jump to the locate to the node to delete, right? So the trick is to use two pointer algorithm, right? So what is the strategy of this problem solution, right? Two pointer approach, right? So because this is only one trick, right? We have to move one pointer in n step ahead. N step ahead means faster. Okay, let's suppose you have given you can say the linked list and you want to remove n equal to 2 means 2 node means n step 2 step ahead you have to faster you have to move, right? We have to move one pointer with n step. N means number of given n from the left side, right? The node that we have given, right? So nth node from the end we have to do, right? For that n is given, right? Nth node from the end. And so when we are going to move, right, with a faster pointer, we will move with the n step ahead, right? Means we want to move one pointer n step ahead, that is called fast, right? And we'll say this is fast pointer. Then we'll have a start a second pointer that is called slow. Okay, so we'll create another pointer that is called slow and we'll start a slow pointer from the head. So both will start from the head itself, right? But faster pointer with n step and slower pointer with slow point means one step ahead only. Okay, when the fast reaches the end, slow will be just before the node to delete. We'll see the visualization and you will understand, don't worry. Okay, then we'll move both pointer one step at a time, right? We'll start what? Slow pointer and fast pointer both from the head, but fast pointer will move n step ahead. Slow pointer will also start from the head, but will move both pointer one step at a time. So for the first time, fast pointer will move to 2, right? But after that, we will go, both pointer will move one step at a time. Okay. Now, when all the pointer do that iteration, right? At the end, when the fast pointer reaches at the end, it means it has the next pointer is null, right? And so the slow pointer is just before the node to delete, right? And so we will just unlink that node and will return the head that we have seen in the example, right? We'll see again, don't worry. Now think, if we will go for the fast and slow with two pointer techniques, so to compute or to remove the nth node from the end of the list, it will take O of n times, because just we have to iterate all the node in the list, right? So it will take, if n is the number of nodes, it will take O of n times. We do not have to take any extra spaces because just two pointer things, right? So we'll take O of n space. So let's suppose the approach, right, means first of all what we are going to do here, right? So we'll create a dummy list. We'll create a dummy node, you can say dummy node, right? And this will points to the head. Why? Because it will help you to handle edge cases like deleting the head node. Okay, so when we are using the two pointer techniques, right, we can easily delete the, you can say, nodes. Okay, then we'll do initialization of fast and slow pointers at the dummy node, and further we'll move n plus 1 step ahead. Let's suppose faster is here, so it will move n plus 1 is, it will go to here, and after that, once you are here, we will go the first move, slow will go here, fast will go here. Slow will come here, fast will go here. Slow will come here, fast will reach to here, right? Means first we will initialize these two pointers, fast and slow at dummy, right? And why we have created the dummy? Because we have created dummy that will points to the head, right? And it will help you to handle the edge case, like deleting the head node if it is required, right? If you talk about the fast and slow, right? So we need two pointers because we have to handle through the two pointers algorithm, right? So the fast and slow will points to the dummy node, right? So this is technical. Dummy nodes, let's treat as a head, okay? And null, you know that, right? So if you think that dummy is a node, right? It's similar to head, right? So just think like this is a head, okay? Now two pointers we have initialized, fast and slow at the dummy, right? Now we have to move fast pointer n plus 1 step ahead, right? And this will create a gap of n uh, between fast will be, let's suppose, here, slow will be here. So there will be n plus 1 step ahead it will go, right? Means 3 step it will move here, right? Let's suppose if we will move right, it will move right initially, means fast will become n plus 1. N is what? 2. 2 plus 1 is 3. So 3 step ahead we have to go. 1, 2, 3. We'll reach the fast will reach to here. Means we have moved a fast pointer n plus 1 times, means n plus 1 step ahead, and this will create a gap of what? N, gap of n, means 1, 2, yeah, 2. There is 2, gap of 2, gap of n, you can say n is 2, gap of n between fast and slow, right? Means 2, there is 2 gap. After 2 it is reaching here, right? Now we'll move both pointer one step at a time. So let's move. So we want to go to from fast to here. At fast should point to what? Null. When the fast will reach to the null, our job will complete. So we will move both until fast hits the null, okay? Now for the moves, right? If we go for the first move, right, we want to move both pointer one step at a time. So let's continue until we reaches at the end, right? So when iteration 1 will happen, it means move 1 you will do. It means slow was where? At dummy, and fast was where? 3. So first move will make one step ahead, right? We was where? Dummy, start slow was at dummy, fast was at 3. So we'll take one step ahead, means we'll reach to, slow will reach to 1, and fast will move from 3 to 4, right? Means in the first iteration, means first move, dummy will come to 1, then it will also come from here to here, right? Means 3 to 4. In the second move, we will take a second move like this, right? So this was iteration 1, we'll move to iteration 2 like this, and so we'll move to the next step. So in third iteration, means move 3 will do, the fast pointer reaches to the null, right? So until we reaches to the end, means null will keep moving, okay? So this is smaller list, but if you have bigger list, still you have to move till the fast reaches the end, right? That is null. So how you are going to remove this, right? This one. So who will remove this, right? The node to remove is slow dot next. Very slow, 3. So just before 4, slow pointer reaches to the third node. When the slow reaches to the third node, it means just before that there is a node, and that we need to delete it, right? So we have to update this slow to means slow dot next is 4. Now just we need to do slow dot next, we will move to 5. Currently 3 dot next, node 3, node 3 is here, node 3 dot next is 4 equal to node 4, but I want to update node 3 dot next equal to node 5. If we will do means we will link 3 to 5 and this will be get discarded, right? So now fast is at where? At the end, means at null, and slow is at 3, just before node 4. And so we only need to link it again, do the relinking again with the 5 and remove this from here, right? And then we will return dummy dot next at the end, and you will get the new head of the linked list. Okay, it means when we are reaching here, slow is reaching just before the node to delete, right? Means we just need to update the next link, right? So just because each node contains data and the next node link, right? So just we'll update the next node link and your job is done. It means we have to do like this. Just remove the node, target node, right? And to remove the target node, what you have to do? Slow dot next means this point, this node I'm showing. What is slow? Slow is node 3. Means slow dot next will move to slow dot next. Means we are discarding this one. So previously it was pointing to here. Slow dot next is what? This. So we'll do slow dot next means this to this. Means we are pointing directly to here, like this. I hope you understand, right? Just you need to do slow dot next equal to slow dot next. Slow dot next is what? 4. We have to do what? Slow dot next is 5. Means at this place you remove this one. Linking you have to change. Remove the target node. So the final output will be what? 1 points to 2, 2 points to 3, 3 points to 5. So this is the final output of the linked list. Okay. So if we will do dummy dot next means we will returning the new head, right? Dummy dot next is what? New head. So we'll return from here 1, 2, 3 and 5. 1 points to 2, 2 points to 3. This is the updated list. Okay. I hope you understand, right? Now think about what will be the status of this node 4, because you have link now from here to here, right? So what will be the status? What happened to this node 4, right? We will have in the mind, right? See, each node contains what? Data and the link of the next node, right? Next node link. So next node link we have updated from here to here, right? So what will happen to this? So after removing this node 4 from the linked list, how we have done? We have done slow dot next. It was pointing to 4. Now we have updated to slow dot next, right? So what will happen internally? Let's assume node 4 is slow dot next, correct? Node is, this slow is at here, right? Slow is at here. So slow dot next is what? Node 4, that I am saying here. Node 4 is slow dot next. If we'll talk about the node 5, what is that? Node 4 dot next, which is slow dot next. We can say in another word. So now just we need to do slow dot next equal to 5. Means we have to update this not to 4. No, it should be 5. So you need to do this. We are skipping node 4 here. Just skip it. Okay. But if we will skip that, it means what? The node has been removed. So what is the status of removed node? Node 4, right? So first of all, node 4 is no longer referenced in this list because we have removed it, right? Then we can say nothing in the list point to it anymore. No other nodes is saying that this is my next, right? means any node who have a link of next node who is not uh, arguing here that this is my next node, right? He's not complaining, he's not saying this is my next node, right? So nothing in this list points to it anymore, right? And say it becomes unreachable. Why I'm asking this question, why I am saying that a status of node 4 is what? Because interview will ask you, if you will talk about you will explain this, right? So he will ask you what will the status of node 4, right? So you should understand that node 4 is no longer referenced in this list. Nothing in this list point to it anymore, because no other nodes in this list is saying that this is my next link, right? Next node link, right? No other nodes are saying, right? So it becomes unreachable, right? In Java, since there is no manual memory management, automatic who is doing garbage collector. So the garbage collector will automatically clean it when there is no longer in use, right? So the garbage collector will automatically remove it because this is no longer in use. But if you are writing C++ code, you have to delete it manually using delete node, right? But in Java, just unlinking it like ever is enough. JVM will take care of the cleanup. Okay. So still in memory temporarily. It will be in temporarily until garbage collector collects it, right? Until it is alive, till the garbage collector is not taking it into the dustbin, right? Then what part of the list it is? No other part. It is unlinked. It is not in the list. Okay. Can it be accessed? Not unless a reference was served before unlinking. Before unlinking, you have to swap with some node. You have to assign with that. If you will not assign somewhere, it will not store somewhere, right? It will be discarded. Because it has been unlinking. Okay. So final status is garbage collector is eligible to delete it, reference it, or remove it. Okay. So if anybody will ask in the interview, if interview will asking that, okay, you have just made a new next node of the 3 from 4 to 5th. From 4th node to 5th node, you have just made a new linking. It means you are unlinking from 3 to 4. What is the status is now for the 4? Because you have just unlinked from here and you have created a new link from node 3 to 5 and you have removed the node 4, right? Then what is the status of that? So he also want to understand the data structure and also about the technology understanding, right? So you should aware with that. If you're using C++, you should know how to do that, right? If you're doing Java, you should know what is happening internally, right? This is the some challenges in Java. Okay, let's understand the solution. So let's suppose class we have given and the main function we have given. So in the main function we have to return the head again, right? And the list node we have given as a head as argument and the nth node that we have to delete. So we will create a dummy node pointing to head to handle edge cases, right? And we have a list dummy equal to new list. We'll create dummy.next equal to head. Then we'll initialize 2 pointers, right? List fast equal to dummy. Then we'll create list node slow. Both will point to from dummy. And then we'll create a for loop. We will go for all the nodes. We will move faster pointer n plus 1 step ahead so that the gap is n between slow and fast. So fast is fast dot next. And similarly, we'll do the once this is done, right? Means we have moved already the faster at the nth step ahead. Then until faster not moving to the null, fast equal to fast dot next, slow equal to slow dot next. We keep moving until we'll reach to the null, right, at the end. Once this is done, it means slow is at the node. To remove it, just do what? Slow dot next equal to slow dot next dot next, and then you have to return the list starting at the dummy dot next. You will do, because we have updated what? Dummy is what? Dummy is what? At 0. So dummy dot next is head. So you will need to return dummy dot next, right? And that will your answer, because we have the reference is there. Dummy is a node dot next means head. We are returning head. So new head is what? Dummy dot next. Okay. I hope you understand, right? So thank you guys. Thank you for watching this video. Thank you all the viewers. Please support Expert Funda and please subscribe and like this channel, right? Please like this video. Please subscribe this channel. Thank you. Thank you for watching this video. Thank you guys.